Good morning, I'm Jordan Josdan, and here's my partner, Andres Valentino. We have conducted a 7-week research on machine learning in breast cancer detection using the CBIS-DDSM dataset.
Right, for the data review, we look into 20 different researches relating to breast cancer and machine learning. With the top of each segment is the title of the research, while under each of them is the link source to them. Next. For the purpose, the problem we tackle on is at the inaccuracy breast cancer detection with the traditional mammography. As for the solution, we utilize machine learning to enhance the detection accuracy. And as for the current condition, there is a growing interest in machine learning for breast cancer diagnosis. Next. For the state-of-the-art model, we utilize Inception P3, which is characterized by pre-trained on large datasets, optimization and negotiation, and inception models. Next. The most datasets which were in the literature review were the Cancer Genome Atlas, or TCGA, and Digital Database for Screening Mammography, or DDSM. Next. The dataset we used, which were DDSM and CBIS-DDSM, consist of the digital database of mammograms, 55,890 training examples, which is preprocessed and converted into 299 times 299. And they have two classes, which are 0 for negative and 1 for positive. And then they have 40% of them are not for positive, while the remaining of them are negative. Next. As for the metrics, we used 1 accuracy, 2 precision, 3 recall, 4 F1 score, and 5 ROC AUC curve. And the formula are given each below. Next. As for our workflow, we first collect the data, then we preprocess the data by recording the TF record data set, shuffling and casting, then defining feature dictionary. Third, we use the image samples for visualizations, then preprocess the image for parsing and decoding them, as well as resizing them, then preprocessing them. After that, we build the model, which is Inception P3, by compiling and training it. And finally, we evaluate that model based on the metrics mentioned earlier. Next.
Okay, here's the data preprocessing and image preprocessing. For the code, we have two main functions, which are the parse function that takes on the next sample and a feature dictionary to parse TF record, and the read data function reads the TF record file, shuffles it, and cache it. Shuffling the dataset is vital to introduce randomness in the training data, as this randomness prevents the model from learning any similar patterns or sequence in the data. The dataset is then mapped to parse each record and decode the image data. Finally, the image, which are initially in a 299 times 299 pixel format, are resized to a more manageable 224 times 224 pixel size using this OpenCV CV2 resize method. Furthermore, for our method here, the Inception V3 expects the input image to have 3 channels, which are RGB. So we merge the single channel grayscale image with itself 3 times using CV2 merge. Okay, so here's the code to define the file path. Then we call the read data function for each TF record file in the mammography dataset to read them all and preprocess the data from each file. Next, from the data split in this code, we convert our list of image and labels into NumPy arrays of X and Y. We then split our dataset into training, validation, and test sets using the train test split from scikit-learn. And we next split the data into 80 to 20 ratio for training and testing. Then we further split the test set into equal parts to create the validation sets, thus creating the ratio of 80 to 10 to 10 for training, testing, and validation. Next is the visualization in this line. We visualize the first image from the training set to give us a glimpse of the preprocessed mammography image. And next is the model building for Inception V3. And for this, we initialize the Inception V3 with an input shape of 224 times 224 pixels and 3 channels, which is RGB. The weights are loaded from pre-trained ImageNet data, and we exclude the top classification layer to enable us to customize the model. Next, we create a sequential model and add pre-trained Inception V3 based model. Then, we introduce dropout to prevent overfitting, flatten the output, and apply batch normalization for reducing the vanishing gradients. And for the dense layer, we use ReLU activation as it introduces non-linearity that helps the model to learn discriminative data. And for the kernel initializer, as we can see, we use curated uniform. Why? As this optimally sets the weight in dense layer and beneficial from the ReLU activations. And for the final layer, we use the sigmoid activation because it is well suited for binary classification tasks. Sigmoid outputs values of 0 or 1 that represents the probability of the input belonging to positive or negative. And next is the train model. We train our model on the training data while validating on the separate validation sets for 20 epoch and with a batch size of 128. And next is the predict binary classification. Using the train model on the test data, and the probability threshold is 0.5 applied to the classification, predicted as 0 or 1. Next is the model evaluation. As you can see right here, we use the scikit-learn matrix to evaluate the model performance. We calculate the accuracy, precision, recall, and F1 score for binary classification using the predictions. Besides that, we also compute the ROC-AUC score using the predicted probabilities, considering as it is a multi-class problem. So we use the OVO, not the OVR one. OVO stands for 1 versus 1 because it is a binary classification. Lastly, we use the macro averaging, as you can see right here, because it is a micro averaging computes the matrix as it calculates the metric independently for each class and then takes the unweighted mean, thus meaning that it is treating all classes equally. Now, for the training results, we can see the graph right here for the training loss and accuracy. And here is the result for the testing. Next, we create the ROC AUC graph using this, and this is the graph from the code. Now, for the other three models to compare the performance, first is artificial neural networks or ANN, which uses the neural network. Next is VGG16, which is similar to Inception V3, which is a CNN and specifically designed for image classification. And lastly, decision trees are non-parametric models that construct tree-like structures based on feature values. And for the model building on ANN, we don't use pre-trained data like before, like in Inception. The sequential model was created similarly to the Inception, and we used dropout, flatten, batch normalization, just like Inception. And for the dense layer, we also use the ReLU activation. For the kernel, we also use the curated uniform. And final layer is also sigmoid activation. Then we compile the model using the Adam optimizer. And now for the training result, here's the result for the training and validation, loss and accuracy. And next is the testing result. Here are the metrics involved, and here are the ROC-AUC graph. And next is the VGG16 model building. Now for the VGG16, similar to Inception V3, we create a sequential model and add the pre-trained VGG16 base model. The rest of the model building are the same as Inception V3, such as using the same number of neurons and using the same activation functions. And here are the training results. These are the test results, and this is the ROC-AUC. And lastly, we use the decision tree for this model. We utilize the scikit-learn library to implement a decision tree classifier. Initially, we shaped the input image data from their original 3D format to 2D flattened arrays using the reshape function. This transformation is necessary to fit the data into the decision tree classifier, which expects a 2D array as an input. And next, we create a decision tree classifier model with fixed random state. We then train the classifier using the fit method. After training the model, we proceed to make predictions on the flattened test data using the predict method, which outputs the predicted class labels. And from there, we obtain the probability estimates for the positive class using the predict program method. and extracting the probabilities from the second column of an output array. And here's the test result for the decision tree. And this is the ROC-IUC. Now, for the metric comparison table, we can see which have the highest percentage indicated by the green columns and the lowest ones indicated by the red columns. Insertion filter has the highest accuracy of 90.72% and have the highest ROC-IUC score with 90.6%. Meanwhile, the other CNN model, which is the VGG16, has a similar accuracy. However, VGG16 lead in terms of precision recall and F1 score. And ANN model shows a promising accuracy but have the lowest recall and F1 score. Next is the decision tree, which is the worst model.
Right. From this, we can conclude that one, insertion V3 and VGG in general outperform the artificial neural network and the decision tree across the most metrics mentioned earlier. And secondly, the insertion V3 has the highest performance across the most metrics before, which makes it potentially the most effective model among the ones tested for the given task. And last of all, insertion V3 is highly suitable and reliable for broader clinical applications in breast cancer detection. Thanks.
Okay, that's all from us. Thank you for listening to our video, and goodbye.